Welcome to this fifth video of lesson Pythagoras Theorem of Standard 10th Mathematics Part 2. In previous video we have seen how to solve first 6 questions of practice set 2.1. Now let's solve the remaining sums. So let's see what is the question number 7. Here it's given in this figure that in DEF, this angle DFE, this is right angle. FG is perpendicular to ED. If GD is 8 and FG is 12, you have to find EF. This is the we have to find. Then we have to EG. This is EG, then FD, and then EF. So we have to find these 3 segments. Okay. So let's see how to find this. So answer number 7. Okay. Now in triangle DFE, or you can say DEF, angle DFE is equal to 90 degrees. So basically we know that this is the right angle triangle, and this FG is perpendicular segment on the hypotenuse DE. Okay. So now we can, if we know this, one of the segment of this GD and FEG, that it is 8 and this one FG is 12. Now using the geometric mean property, we can say that FG is geometric mean of segments EG and GD. EG and GD. Therefore, FG square is going to be equal to the product of EG and GD. Okay. Now FG is given to us, it is 12. Therefore, 12 square. We do not know AG, and GD is given to us 8. To find EG, we have to divide this 12 square by 8. Okay. So you can write this 12 square as like this, and dividing by 8, you can get it EG. So just divide this 8 by 4. If you divide by 4 2s are, and here 4 3s are 12, 2 1s are, write it down, and 2 6s are. So you get EG is equal to 3 into 6, that is 3 6s are 18. So we got our first answer of length of segment EG. Now to find FD. Okay, this is FD, how we can find an EG. Okay, so now when you add this ED, you can get DE. Now DE is what? DE is nothing, it's addition of EG plus GD, because from the figure we know that between is E dash G dash D, and therefore DE is going to be equal to EG plus GD. That is, here we got this 18 plus 8, therefore DE is equal to 26. Okay. So now we have got this. Now to get this, DF, we can take the right angle triangle DFG. Okay. Now in triangle DFG, we have this angle G is right angle, and that's why now its hypotenuse is going to be DF. Therefore DF square is going to be equal to GD square plus GFG square. Okay. So DF square, which we want to find, GD, it is given to us 8 square plus this to FG is 12 square. Okay. So what is 8 square? 8 square is going to be 64. 12 square is going to be 144. What is the addition of this? 4 plus 4, 8. 4 plus 6 is going to be 10. 1 carry is 208. And therefore, let me write over here, or we can rub this portion over here, and its answer. Therefore, DF square is going to be equal to 208, and therefore DF is equal to square root of 208. Let's see what are the factors of 208. Suppose we divide it by 2, then 2 1s are, 0s are, 2 4s are. If you divide by again 2, 2 5s are 10, 2 2s are 4. If you divide this by again 2, you will get it 26. Dividing by here, you will get it 13. Now 13 is a prime number, so we get this, and here if you write 13, 1, 13. So this is the pair of this. So it's is equal to df is equal to, it's under square root of 2 square into 2 square into 13, and therefore df you can get it as 2 into 2 root 13. It means it is square root of 2 square will give you 2, square root of 2 square 2, and square root of 13 as it is. So we get df is equal to 4 root 13. Okay. Now here, so with the help of Pythagoras theorem we have found. Now in this triangle also, EFG we can use 12, and now do we know this? Yes, EG we know this. EG we have got it is 80. Okay, so we have got this answer 80. Now using Pythagoras here also you can find this EF, or if you know the whole or this just now which we have found, with the help of this triangle we can get the remaining. So we have two options. Either we can use triangle FEG, or in triangle EFG, where angle G is going to be 90 degree. So using Pythagoras, EF square that is hypotenuse, which is opposite to right angle, is going to equal to EG square plus GF square or FG square. So this is Pythagoras theorem, where we can write that result. Pythagoras theorem. In the previous triangle also, this triangle also we can write this Pythagoras theorem. Now EG square is your 18 square plus FG square is 12 square. We know this is a 12 square. So now taking 18 square is 324 plus 12 square. 12 square is 144. So take the addition of this. 4 plus 4 is 8. It's 6. 3 plus 1 4. 468. So EF is going to be under square root 468. Now to get its factors, to convert it into this mixed, okay, what we can do, we can get the factors of 462. If you divide this by say 2, you will get it 2s, 3 and 4. If you divide it again by 2 1s are 2 1s are 2 7s are. Now this is divisible by 7 plus 1 plus 8 9. It is divisible by 3. 3 3s are 9. 2 remains, 3 9s are 27. Again by 3 1s are and 3 3s are. Okay. So this is the product of 2 square into 3 square into this 30. So here you can get it 2 into 3 into square root of 30. That's why EF is equal to 2 3s are 6 root 30. So we have got this answers of this 3. Okay. So we can write this answer as a final answer, that 3 distances. EG is 18, DF is 4 root 13, and EF is 6 root 13. Okay. So here we did not require that DE, because we have taken this triangle, small triangle. But if you take the bigger triangle, then having this DE as 26 and DF as 4 root 13, you can get this way also. So that's why we have found this. But anyway, this is also this way also we can find. Okay. So after this question number 7, where we have used just theorem of geometric mean and Pythagoras theorem, we could find the required segments and their lengths we could find. Okay. Now let's go to the next question number 8. Question number 8 is find diagonal of a rectangle whose length is 35 cm and breadth is 12 cm. So let's see answer number 8. It's a rectangle. So let's draw a rough figure of rectangle whose length is 35 cm and breadth is 12 cm. So B is equal to 12 cm. And we have to find its diagonal. Okay. So let's name this rectangle. Say let's ABCD. Okay. So let's ABCD is a quadrilateral ABCD is a rectangle. Okay. Where the length is given BC, you can take it. Where length BC is 35 centimeter. Okay. And breadth, either you can take BC or you can take AB. AB is equal to 12 centimeter. And now we have to find diagonal AC. Diagonal AC we have to find. Its length we have to find. Now as for the sum of square, we have taken the property that all angles are right angle. Even here in the rectangle also, each angle is going to be a right angle. Hence this triangle ABC is a right angle triangle. So let's using that property. In triangle ABC, angle B is equal to 90 degree. Why it is? It's angle of a rectangle. It's angle of a rectangle. Okay, so we can write this reason like this in the bracket, and therefore in triangle ABC is a right angle triangle. Therefore we can say AC square is equal to AB square plus BC square. Here we have used the Pythagoras Theorem. So we have to write this Pythagoras Theorem. Okay. Now substitute the values which we know. AB is 12 square plus BC is 35 square. If you remember, I have given you one triplet in first video of this lesson, Pythagoras Theorem, Pythagorean triplet. Here I have given you 12, 35 and 37 is a Pythagorean triplet. So if you have these two sides, two numbers, 12 and 35, the rest must be your 37. Okay. Now if you know this triplet, you know your answer. Okay. But if the question comes for the multiple choice question, you need not to solve all this thing. With the help of just triplet, you can directly in few seconds you can tell that answer. The diagonal of the rectangle should be 37. We can check here. Okay. So how knowing this triplet is how useful you will come to know. What is this 12 square? It is 144. 35 square. Now 35 is a big number, but still we have some technique to find the square of such number where the n digit or a digit in the unit place is 5. And I hope you know this technique, that 35 square. How we can get it? First write what is 5 square, that is 25. Now the rest number is here 3. Okay, what is the consecutive number of 3? After 3, which number's natural number comes? It is 4. And what is the product of 3 and 4? It is 3 4s are 12. Copy this 12 before your 25. So this number is your square of 35. So 35 square is 1225. Okay. So this way we have done. Now take the addition. 5 plus 4 is 9. 4 plus 2 6. Then 1 plus 2 is 3. And here 1. Okay. Now AC square is 1369. So what is AC? It is at a square root 1369. Or you can say this is just, you can do one more thing. So find out first this is the square of which number. It should be a perfect square. So to get it square. Now if you know this triplet, that 12, 35, 37, you just check whether is it the square of 37. Okay, so you can multiply with 37 into 37 and get the confirmation. 7 7s are 49 here. So 7 3s are 21 plus 4 is 25. When you multiply by 3, put a 0. 3 7s are 21. Here 2 take the point. 3 3s are 9 plus 2, 11. So if you add this, what you get? 6, 3 and it's 1. So 1, 3, 6, 9. Yes. So it's a square of 37. Okay. So this is for just confirmation. Okay. Actually you should be knowing that it is perfect square of 37. Now AC square is 37, 7. So AC is going to be 37. Now AC and all that we have taken for our convenience. Your final answer should be the diagonal of the, you can write that what is the diagonal? So the diagonal of the rectangle is 37 centimeter. Don't forget to write centimeter, because in the question it is given the unit along with 35 is centimeter and 12 centimeter. So this should be also 37 centimeter. So in this way, so if we know the triplets, as I told you in that video also, as you learn some tables, some squares and cubes like that, we should be knowing this Pythagorean triplets. They are very much helpful to us. Okay. So after this 8 sum, let's see what is the 9 sum. Okay. Here, now let's rub this answer and move to the question number 9. Okay. Now it's question number 9. M is midpoint of QR. Where is QR? This is your QR. So M is midpoint of QR and angle PRQ is 90 degree. Prove that PQ square, this is PQ square, is equal to 4 times PM square, this is PM square, minus 3 times PR square. It's very confusing to how can we get, but I will give you one simple technique, one smart tip, that what you do, first find the rough work, and in that try to get what is PQ square, what is PM square. Try to get these values and then see if you put it here, do you get it or not, and how do you get it. So from where you can get PQ square, now this is PQ square. Now because this is a right angle, you have there, this is a right angle triangle. So first right angle triangle is PRM, correct? This is a right angle triangle. And the another triangle is PRQ, this is another right angle triangle. Of course this triangle we have, but this is not a right angle triangle. We will consider these two right angle triangles where now PQ square is in this triangle. PQ square is triangle PRQ. We can get PQ is your hypotenuse. So PQ square, you can get it with the PR square plus QR square. Okay. So this you can get PQ square. From where you can get PM square. Now PM square is, PM is a hypotenuse in triangle PRM. So PR square is going to be, PM square is going to be PR square plus RM square. Okay, RM square. And from where you can get PR square. Okay, we already have got PR square. So these two things we have got, and one more thing we have, that is RM is equal to MQ. Okay, or what is QR? QR, and therefore, so it is midpoint. So QR is 2 times RM. 2 times RM. This also we can have this. And then if you want QR square, it will be square of this. 2 times RM square, you will get it 4 RM square. Okay. So what is your LHS? Left hand side, still we are doing the rough work only. The left, RHS. RHS is the big enough. So let's start with RHS. 4 times PM square minus 3 times PR square. This should give us PQ square. Okay. So how can it give us to PQ square? So 4 times PM. What is PM? PM is PR square plus RM square. So it is PR plus PRM square minus 3 times PR square. Now PR we do not have any separate value, so let it be 3 times PR square as it is. So 3 times PR square, let me write over here only. Okay. Now take the multiplication of this 4 times PR square plus 4 times RM square minus 3 times PR square. Okay. So 4 PR square minus 3 PR square, like terms. So 4 minus 3 you will get it 1 time PR square. And plus, what is this 4 RM square? 4 RM square is nothing but it is equal to QR square. So this you can replace as QR square. And what is PR square plus QR square? This is nothing but this is your PQ square from this statement. So here you can get it as PQ square, which is your LHS. So if you do this calculation before, you are sure that what you are going to require and how you have to prove. So you can start with RHS and you can come to the LHS. So you can show LHS is equal to RHS. But before that, you require certain statement. This is first, second, and this third you may require. So you have to write this first 3 statements and then you can start with this process. So here is something like we are solving algebraic equations in geometry. Okay. So answer number 9, if we start, so in triangle You see in triangle PRQ, angle R is equal to 90 degree, so which is given over here, and therefore by Pythagoras theorem PQ square is equal to PR square plus either you can say RQ or QR, anyway you can say QR square. As we are going to use this statement here, we will say this is statement number 1, and the reason is Pythagoras theorem. Okay. Now in triangle PRM, again angle R is right angle 90 degree, this one, so which is also given here, and that's why we can say that PM square is equal to PR square plus RM square. Statement number 2, again the reason is Pythagoras theorem. Now as we have an idea in which way we have to solve, so let me rub this part over here. Okay, this is statement number 2. One more thing which we are going to require, that point M is midpoint of RQ. This is also given, and that's why you can say that QR is 2 times RM, and therefore QR square is equal to, squaring both sides we will get 4 times RM square. So this is statement number 3. This statement is third statement. Okay. So now we have written the required statement. So now let's write the right hand side. RHS is equal to 4 PM square minus 3 PR square. Just now we have already seen how and which way we are going to get it. So we have to write the same thing. So 4 times PM square. PM square we are going to get it from statement number 2. Okay, it's PR square plus RM square minus 3 PR square from 2. Statement number 2. We have replaced the value of PM square as sum of this squares. Okay. So simplify this. It is 4 PR square plus 4 RM square minus 3 PR square. Now subtracting this 4 PR square minus 3, you get it PR square one time, plus now this you have to replace 4 RM square is equal to QR square is equal to, here you will write QR square, here you can write from 3, and now addition of these 2 is your PQ square. Okay, this is going to be equal to PQ square from 1. So in this way we have proved is equal to your LHS, left hand side, and therefore you have proved that it is PQ square is equal to 4 times PM square minus 3 times PR square is proved. Okay, so these are the 3 questions here we have solved. The next question is also easy, the word problem. You just draw the figure. Once you draw the figure, you have to use only Pythagoras, and with the help of Pythagoras theorem you can solve the remaining 10 sum from this exercise. So here we have finished all the sums from practice exercise 2.1. If you want that sum also to be solved in the video, you just let me know in the comment box. I will solve that sum also for you and send a video on that. I hope you have understood all these sums, how to solve. It's very easy, and basically if you know the Pythagorean triplets, it is very much helpful to you to solve these sums. Thank you very much. If you like this, give likes, comments, and yes, if you are not yet subscribed.